Brett's going to introduce us to the ASP.NET Web API.
Thank you.
Thanks, Brett.
All right, well, my name is Brette Esterbrooks. Again, thanks to W3I and the user group, I'm pretty excited to be here. I've never attended the St. Cloud user group, so it's kind of nice to come down here, and I've never been in this building. I was telling some of the people here that I'm working with a startup in the city right now, and going through their plan for the next couple of years. There's a big bullet point for W3I, so it's pretty cool to see a company doing so well from Minnesota. So thanks for hosting. Again, I'm Brette Esterbrooks, and today, in this beautiful winter night, we're going to be talking all about the ASP.NET Web API. But before we get into that, just a little bit about who I am. I'm a software developer. I'm an independent consultant in the Twin Cities area, and I've been doing software development now for about 10 years, and of 7 of that, I've been doing it as an independent. And as I've kind of ping-ponged from project to project, I've also traveled quite a bit through the .NET stack. I started out doing ASP.NET, moved to doing some WCF. I did a really long stint where I was doing WPF and Silverlight. And of course, most recently, all of the good stuff that we have in the MVC stack, including the new Web API. Now, outside of my work life, I'm also a member of the local chapter of TechMasters. Is everybody here familiar with what TechMasters is?
Yeah.
For those of you who are not, TechMasters is actually a Toastmasters chapter. But it's a Toastmasters chapter with a bit of a technical slant. So what I mean by that is most of our members are actually working in technology, like us, or they have an interest in technology. So as a result of that, most of the stuff we talk about, most of our presentation content, revolves around technology. So if you were like me, who found myself sitting behind a computer 12 hours a day pounding out code, didn't give me any time to work on any of the other skills that are pretty important, such as presenting, running meetings, listening, or just general communication skills, TechMasters is a really great place to kind of practice this stuff. And if you're not interested in that, it's a really great place to network, because we all work in technology, so it's a great place to meet people. So if you have any questions about TechMasters, I know we're in St. Cloud, so it's a pretty long drive on a Tuesday morning. Definitely come up to me after the presentation. I'll be happy to tell you more about it. So introductions out of the way. Let's go ahead and get started with what we're here to talk about. Just so I can get a feel for the demographic of the room, how many people here are currently working with WCF? MVC? Yeah, a lot more of you. Is anybody currently working with the Web API? Okay, good. Well, as most of you probably know, with MVC4, Microsoft introduced us to a brand new, shiny framework called the Web API. Now, anytime new frameworks come out, you have to ask yourself a few pretty basic questions. The first is, well, what is this? What is this new framework? Answer to that's pretty simple for Microsoft. It is the new recommended approach for how we do RESTful services or HTTP-based services in the .NET stack. But the more important question is why? We have MVC, we have WCF. Why introduce something new to an area of the .NET stack that's already a bit confusing? Now, to help illustrate the answer to this question, I'm going to show you a few pictures, and I'm going to go through them really quickly. But as I do, I want you to ask yourself a question. What is it that's causing these people so much stress? All right, so first is our distressed woman. If you've worked with the first version of the entity framework, you probably know this pain. From our distressed woman to our frustrated man, from frustration to anger, and from anger to complete loss of self-control. And that's actually what I looked like earlier this afternoon at a client. So the story, in my mind, that kind of plays out, this is a group of developers, maybe 3 or 4 developers, who for the last 3 or 4 years have been working on a suite of REST-based services. But because of the company that they work for and the wonderful corporate IT standards, they've been forced to do this using WCF. So for the last 3 or 4 years, this group of developers have been kind of fighting against a technology that was really never meant to solve the problems that they were facing. Now, I don't mean this any disrespect to the WCF folks here or WCF itself. It is still pretty decent and relevant technology. But the reality is from the ground up, WCF was built around and designed for SOAP-based services. It was designed to be extremely scalable, flexible, configurable, and any other IBL you can think of. And it was meant to go over multiple transports, be it TCP/IP, named pipes, or most recently HTTP. And this is all great, it's all really powerful stuff, if it's what you need. But if what you need is just a simple HTTP service to send data to, or to get data from, the WCF development experience starts to feel a little bit like this. Right? It's heavy, it's difficult, it's hard, it's cumbersome. Now this guy clearly understands what that feels like, and so does Microsoft, thankfully, because as HTTP services became more and more prevalent, they made steps to help lighten the load. .NET 3.5, we got the web HTTP binding. For the first time, WCF developers can expose their services as HTTP endpoints. A step in the right direction, sure, but not quite far enough. This particular binding tended to treat HTTP more as a simple transport protocol, as opposed to an application protocol. Basically, they used it as a way to move data from one server to another, but the HTTP semantic is quite a bit richer than that, right? We have things like content negotiation, caching. These are the things that HTTP developers want to target. So a step in the right direction, not quite there. Then we got something called the REST Starter Kit. Has anybody here ever gotten a chance to work with that? Anybody ever heard of it? Well, the REST Starter Kit actually got quite a bit of, I don't know, good buzz around it at first, but unfortunately for us, it never even made it past the community preview. And if you go to Microsoft's technology sites, it's now listed as one of the many retired technologies. So another miss there. Then we got the third and final attempt, which was something called the WCF Web API. Now, in all fairness to the WCF team and Microsoft folks, a huge step in the right direction, in my opinion. We started to see things like convention over configuration, content negotiation. We got a pretty decent client to interact with our services. But this kind of fell into the box of a little, too late. .NET developers like myself were already pretty frustrated moving on to other things. Open source solutions come out, Service Stack, Open Rasta. And some of the more savvy .NET developers even started to host their HTTP services on top of MVC. And even that process was easier than using the new WCF Web API. So Microsoft found themselves in a bit of a pickle, right? They had to make a choice. Do we continue to twist, turn, kick, and shape WCF into something that maybe it was never really intended to be? Or do they take a step back and kind of look around at the community and come up with something specifically to target HTTP services or REST services? And thankfully for us, they chose the latter, and with MVC4 we get the brand new, shiny, happy, yellow, smiling ASP.NET Web API. Taking some of the good from the WCF Web API and what they've learned from the MVC stack, they've managed to come up with a framework that gives us a whole lot of very, very welcome features. We have a much more modern HTTP programming model. What I mean by that is it's convention-based. It's asynchronous from top to bottom. We get a really nice client to interact with our services, and because it embraces HTTP conventions, the development experience is easy. Content negotiation. As developers of services, we need to be very cognizant of the types of data that clients want, right? They may want to use JSON, they may want to use XML. Out of the box, we get both with the Web API, plus the extension points for things like Atom Pub, RSS. If you wanted to do your own media type, if you're doing true REST-based services, you can do that. Routing. And this is going to be something I'm going to keep saying over and over. Because the Web API is built on top of MVC, we get a whole bunch of stuff that we've come to enjoy with MVC, such as routing, action filters, model binding, model validation, and all of the stuff that makes MVC a great framework. OData, if you want to expose your services over URI-based queries, you can do that following some basic conventions. And they keep improving this with each nightly build, actually. They're working pretty hard on this aspect of it. And last but not least, it's testable. For the people here who raise their hands as WCF developers, how many of you consistently write unit tests or integration tests? Wow. I'm not so thorough in my experience with WCF. I've always found it to be a little bit test prohibitive, meaning it's very difficult to write a good test, and the time it took never really justified the cost. I know it's a little bit better now, as was back in the first release. But the Web API is extremely testable. It was developed much like MVC, so every aspect of it can be replaced and tested very well. So that's a really, really great thing, and that's a pretty big difference from what we had with WCF. Now, the last thing I want to just mention in this introduction before I move on to our demonstrations, and this came up like the last time I gave this presentation. Someone asked me, why all the focus on HTTP? What's wrong with SOAP? The answer to that is, well, nothing really. But if you look around at the landscape, the biggest application in the world, the most scalable application in the world, the most understood application in the world, runs on top of HTTP. And of course, I'm talking about the internet. More and more clients understand how to work HTTP almost as if it was native. So as service developers trying to get clients, it makes sense that we are moving to an application protocol that they can very easily understand. So while there's nothing wrong with some of the other things, I do see the trend, and as we all do, moving more towards the HTTP type services. Any questions on this before we go into the first demonstration? Just a little bit of history. All right, so for the first demonstration, we're going to just create a very simple Web API, and in doing so, we'll look at some of the project structure. We'll compare and contrast some of the differences between traditional MVC and the Web API. We'll look at how we can interact with the Web API using Fiddler, and we'll look briefly at some of the content negotiation support. So let's go ahead and take a look at our first demonstration here. So as with anything in .NET, before we do anything, we need a project, right? So say File, New, Project. With MVC4, you're going to get a few new project templates. One of them, of course, is the Web API, so I'm going to go ahead and click OK there. Now as I do this, Visual Studio is going to resolve any missing NuGet references. It's going to do the T4 thing, generate our project template. Now this particular template gives us a couple things. It gives us a fully functional MVC site, as well as a Web API. So the thought with this particular template is that you would be creating a web app that leverages a Web API. Now you certainly don't have to do it that way. You can put your Web APIs in different projects as you like. But for our demonstration purposes, this will be just fine. I should say, I hope it's resolving references. All right. All right, so any of the folks here who are familiar with MVC, this should look pretty much at home, right? We have our view folder, our models folder, which is currently empty, and of course our controllers folder. The project template gave us two controllers. The first is the home controller. Nothing of any real interest here, right? It's your standard run-of-the-mill MVC controller. Derives from controller base and has a simple index action that returns a view. More interesting, though, is the values controller. Right off the bat, we notice a few things here that are a little bit different. We're deriving from a new base class called API controller. This is a class that was given to us with the Web API and gives us access to all the things that we need to work with HTTP, such as some global configuration context, the request, some of the header information, and a few other things we'll see as we dig into it a little bit more. But more interesting, especially if you're not familiar with the Web API, is the naming conventions of these methods. You see we have get, post, put, and delete. And this particular naming convention actually illustrates one of the biggest differences between traditional MVC and the Web API, and that is of course routing. For MVC, if we want the framework to execute a specific action, what's the information we have to give on the URL, right? The controller, the action, and maybe any optional parameters. With that information, the routing subsystem can instantiate a controller, execute a method, and pass along any parameters. But if we look at the Web API here and some of the comments it generated, it's a little bit different. We have this API, we have values, which is the name of the controller, and we have a parameter here. So really all we have is the controller name and the parameter. So how can the routing subsystem then determine which method to call? And the answer to that lies in the incoming HTTP request. HTTP requests can be of various types, as most of you know. Put, post, get, delete. And it's that information that the API's routing system uses to direct method invocation. So if you did an HTTP request to the values controller with a get, it would go here. If you did a post request, it would execute this, a put, and a delete. So it follows the convention of looking at the HTTP request and mapping it to a method name. And I just kind of want to show this quick because if there's people here who aren't real familiar with some of the convention-based stuff, it's kind of interesting. So let me go ahead and F5. Is everybody here familiar with Fiddler? Fiddler is one of the great tools that can't really do much without. So I'm running this project and we see basically the index page of the MVC site that this project template has. I don't really care about that. I'm just going to cheat and steal the port here. And if we go to Fiddler, I'll go to the composer here, and I'm actually going to send a request to our values controller. And I'm going to do an HTTP GET request. Here's all the various types of requests we can do. Go ahead and execute that. And you can see here, because we did a GET request, we were routed to the GET method. Not doing anything interesting here at all, right? We're returning an enumerable of strings, so I'll go ahead and let that go. And you can see that our response, by default, comes back in JSON. Similarly, we can do the same with a post. And we come into the post method. We can do put, and put, when we're talking about resources, generally infers update, so let's give it an ID. And now we're here in our put method. And just for completeness, let's go ahead and do the delete. Delete requests can have a payload, so let's go ahead and run this. And you can see we're here in our delete method. So this is one of the core differences between the two frameworks out of the box, and again, it's in routing. So in one project with two different routing structures, you may be wondering how that's set up, how they don't collide. And so I'll just show you real quick where that is actually in the project. And if you don't like these default routes like MVC, you can change them to whatever you want. This is just the default convention. If you go to the app start folder, you'll see we have the route config, which has, this is your standard MVC route, right, with the controller action ID convention. We also have the web API config, which specifies the routing for the web API itself. Notice we have this API here, which is just a convention, and the idea here is to help you avoid collisions within your routes. So again, you don't have to have it, but it's something that they do by default to help you avoid collisions. And again, we have the controller and the ID. Action is missing because that is inferred from the incoming HTTP request. Okay, so that particular example is not all that exciting, so I'm going to go ahead and do something a little bit different here. I'm going to change this to orders controller. Let Visual Studio handle that. I'm going to go ahead and I'm going to create a model. Call it order. So here's our order class. Very, very simple model. We have an ID, date, and an amount. We go back to the orders controller. And from this get, let's change this return type to a fake kind of list of orders. Now obviously I'm returning an enumeration of orders here, so I have to change this. We'll get some compile problems. Let me go ahead and rebuild this. If we go back to Fiddler now, we can actually do our GET request here. And we're going to have to change this to orders because we changed the controller name. All right, so you see we're coming into the same execution that or same method we had before. And I'm just going to return this fake list of orders. And what comes back by default is, again, a nicely formatted JSON notation of our enumerable of orders. But what if you didn't want JSON, right? What if you wanted XML? So I talked earlier about content negotiation, and the mechanism in which the Web API handles content negotiation is actually through a header. You can actually pass it an accept header and specify the type of data that you want to work with. So I wanted to show you briefly how that works, because this is a pretty powerful thing, actually. If we go back to the composer, and I just say accept application XML, and run this again, notice we're going to the exact same method because it's a GET request. But this time down here, you can see that we're actually dealing with an XML response. So I open that, you can see we have our nice XML formatted. So out of the box, you do get support for JSON and XML, and I gotta kind of tell you this because I wasted a whole bunch of time on it once. When I first started playing with the Web API, I was trying to understand the content negotiation stuff. I kept sending XML, and I was getting back JSON every time. And I was scratching my head and kind of cursing the framework. I spent a whole lot of time Googling and wasting time. And it turns out that the default formatter that's used is the JSON formatter. But if you ask for XML and your object graph has something that isn't serializable, maybe you have a lazy loaded property using an entity that has dynamic proxies around it, the XML serializer is going to choke, right? But you're not going to get an error. What it's going to do, it's going to defer back to the JSON formatter, and the JSON formatter is quite a bit more sophisticated, right? It can handle a lot more things. So you'll get back JSON. And so I spent about 2 hours just scratching my head, and I finally looked at the JSON that came back and realized it was incomplete. And so that kind of said, oh, there's something wrong with this object. So if you do start playing around with content negotiation, know that you won't always get an error back if the serializers blow up. You may end up getting JSON. So, any questions on this so far before we go on to the next thing?
How sophisticated of hooks do you get into the content negotiation functionality? Like, does it give you like quality negotiation also, or is it just content type?
It's content type right now.
Okay.
I know that isn't supposedly in the future plan, but right now, maybe the nightly builds have something for it, but the released version is just strictly content negotiation. And the framework hooks are there. I mean, you can build a format pretty quick, but yeah. Anything else? All right. Let's go back to. All right, so the next thing I want to talk a little bit about is clients. What do I mean by clients? Well, clients are really anything, any device that wants to interact with our services. It could be a phone app, a browser application, a tablet, camera, a watch, even something as arcane as a home automation system. The reality is that anything that understands how to work with HTTP is a potential client of our service. So what I'd like to do next is show you a few different ways that we can interact with our services with various different clients. But before I do that, I need to introduce you to the sample application that we'll be using for the rest of the demonstration here. And that is a fictional pitbull adoption site called pittylove.org. And the idea here is just to make some of the examples a little bit more relevant. And I'm actually only showing the picture here, and I always feel strange saying this. When I first told my wife the name of the site, she said, show a picture, they may think you're talking about something else. So I'm assuring you it's not underarms, which is the content, it's actually pit bulls. And I have two of the little guys at home, so it's kind of near and dear to my heart. Anybody here own pit bulls? Pit bull pro? No one? Oh, this is the first time. All right. Okay, so we all now currently work in this room, not for W3I, but we work for pittylove.org. And at pittylove.org, we have the following architecture. Let me step out of the way. We have a website that users can go to. They can log in. They can search for dogs that are available to be adopted. We have a web API, which delivers the content to our website, and hopefully to other clients if we continue to grow, right? We have a database that stores all of our dog information. And the first client we're going to look at is a simple jQuery client to interact with our service. And the interaction, we're going to look at the sequence of events that we're going to use. Looks like this. So we're going to use jQuery to make a simple AJAX GET to our web API. Our web API is going to query the database, get all the list of dogs, and we'll return that back to the browser in an HTTP response, with the payload being a JSON representation of our list of dogs. And once it gets back to the client, we're going to use the jQuery templating plugin to render the docs to the screen. Now, I do need to mention that the templating plugin, as far as I know, was Microsoft's first addition to the jQuery project, but is no longer supported. I think it's kind of deprecated. There's other things we're supposed to be using now. So just know that if you go download the code, I'll give you a link. You see that it is actually not really the supported way anymore. All right, so let's take a look at our first client, which is a JavaScript client. All right, so here we are, our pretty love solution. Before we go into the first client, I just want to show a few things here to help make the demonstrations a little bit clearer. We have a model project here that contains our single entity that we're going to be dealing with today. It's a pit bull entity with an ID, a name, a description, and the URL of the image of the dog. Additionally, we have our unit of work pattern and our repository pattern. If you're not familiar with these patterns, it's not a big deal. Just know that if you see the unit of work in the examples, that's how we're actually kind of abstracting out the database. So that's how we're making the queries. All right, so if we go to our first client example here and go to our controller, we know right off the top that this is our web API, right? Because we're derived from API controller. Aside from that, there's really not that much going on here. We have our constructor, which is using dependency injection to get access to our instance of unit of work. It's registered as a singleton. And we have a simple get action. Now this get action basically asks the unit of work to go get all of the dogs and basically convert it to a list. Then we ask the request object to create for us an HTTP response object. And we're going to pass it a status code of OK or HTTP 200. And for the payload of the response, we're going to go ahead and ask it to serialize us, or serialize our list of pit bulls in the specified format. And in this case, we'll be dealing with JSON. One other thing to note here, and you may have noticed this, the first example when we were looking at the GET, we were dealing with a return type of an enumerable of orders, or the default, which is the enumerable of strings. Here we're using an HTTP response message. Both will work, but more times than not, you'll probably end up using the HTTP response message. You get a lot more control over what you do. You can see I'm explicitly setting the status code. If you wanted to specify a different formatter, you could, and you can actually specify exactly what is being sent on the response. So that's really all we have for the controller, a simple get method that's going to return a list of dogs. If we go to our view, which is going to be our index here, I mentioned we were going to be using jQuery templating. Right at the top here, you can see we actually have our template. Now, if you've never used this plugin, it's pretty much like any other templating engine, right? You basically define the markup that's going to represent a type of object. So here we're saying for every dog that comes back, basically render this div, right? Spit out the image URL, the name, and the description. So for each dog, we're going to have one of those divs rendered. And then down here, we're just using the simple jQuery getJSON to make an AJAX request to our pitbull controller. And from there, we hand the data off to the jQuery templating plugin and let jQuery kind of handle most of the heavy lifting for us. So let me go ahead and throw a breakpoint in here, and we can kind of watch this. Now, when I run this, the first thing we're going to see, since that index page that loads has that AJAX request, we're going to see this get action on the controller be the very first thing that's hit. And from there, we'll be able to trace through it. So let me go ahead and run this. All right, so we're going to go to the unit of work, and we're going to query our database and get the list of dogs. See, we have 3 of them in the database. And then we're just going to simply create the response object, ask the request to do that for us, and we're going to send back that list of dogs to the client. jQuery templating goes, and here we have our beautiful list of 3 dogs. And I should mention that all of these dogs are actually adoptable. I've completely stolen without permission this data from a pit bull rescue in California called Bad Rap, so I feel like I have to give them a bit of a shameless plug since I took the data. So really pretty straightforward. We have 3 different things, right? We have the action in our Web API controller. We have a simple jQuery template and a simple AJAX call, and works out pretty well. It's not a whole lot of code and pretty straightforward. Any questions on this before we go on to the next client? No? Clear as mud? All right. So we've seen a few different examples now of getting data from a service, right? We got the list of orders, we just got a list of dogs. But what if you want to update a resource or create a new resource? What if you want to send data to the service? So the next example I'd like to look at is a way that we can actually update these dogs. So what we're going to do, and I'm going to run this first just so I can show it to you. We're going to basically make a slight modification to our existing app, and we're going to just throw an edit link on there so the user can go ahead and edit the dog information. So you can see here we have the same list of dogs with this edit link. Now when I click this edit link, a few things are going to happen. I'm going to launch a jQuery dialog to render a form. When that dialog loads, we're actually going to go back to our Web API and ask for that specific dog by ID, so we can render the most up-to-date information for that dog. So there we go. Now I can cancel the dialog. We'll just close. But if I click save, we're actually going to send this data back to the service. And the way we're going to do that is through an HTTP put. When our Web API gets the form submitted, we'll go ahead and we'll persist that to the database. So let me go ahead and make a change here. We'll call her, change the dog to food, and call her Green Olive. And you can see we've refreshed the list there, and we have successfully renamed Olive to something edible. So let's take a look quickly at the code that we can kind of make this happen with. Our controller is going to look a little bit different this time because we've added a few new calls. So we have our same constructor that kind of gets injected with the unit of work. We have our same get method that returns the list of dogs. But down here we have 2 additional methods. We have a get by ID, which takes in the ID. We ask our unit of work to go get the pit bull repository and get me a specific instance by its ID, so we're getting the most recent version of Olive in this case. And then the same thing, we're just going to create an HTTP response off the request, status OK, with the pit bull that we just got from the database. And then down here, when we click the save button, we're going to be passing along the serialized form. It'll get model bound into a pit bull. And we'll go to the database, and this is kind of if you're familiar with the entity framework, I'm cheating here, because I need to, in order to make an update, I need to bring it into the context. So I have a comment here that says I'm getting it to get the most recent changes, but it really isn't. I'm cheating. So I'm going to go get Olive from the database, and I'm going to basically apply the changes. Ask the unit of work to commit those changes. I'll send it down to the database, and then, as with most things HTTP, I'm going to return the updated version of the resource back to the client. So that's some of the changes in the controller. But if we look at the UI, there's a few other changes in there as well, obviously because we have a form now. So again, we have some similar things. We have our template that renders the list of dogs with the addition of this edit link. Down here we have an additional jQuery template that's going to render our form. And this form has inputs for the name, the image, and the description of the dog, and of course the 2 buttons, which is the cancel button and the save button. So 2 templates, one for the dialog, one for the list. If we scroll down here, we have the same AJAX GET request that's going to pull back the list of dogs. There's a fair amount of JavaScript here, but really the only thing we're really interested in is what happens when save happens. So when we click save, the submit handler is going to run on our form. And you can see here, I'm doing an AJAX put to our Pitbull controller, also passing along the ID on the route, and I'm serializing the entire form into the body of the request. If I get a status code 200 back, which means everything went good, all of it was resaved to the database, I go ahead and I close the dialog. So let me go ahead and again throw some breakpoints in here so we can kind of watch this interaction. For debugging. So this is gonna, if I hit F5 here, we'll end up back in our get action that returns the list. We're going to launch the dialog, which is going to do the get by ID. See, I'm passing the ID along. I'll use dog number 1. I'm going to grab all from the database and send that back to the client in the HTTP response. And let's make Olive's name less green and go ahead and click save here. And this is going to do the AJAX HTTP put that we saw, which is essentially going to call our save method. So I'm cheating, and I'm mapping, committing, and returning the resource back to the client. And then we refresh the list too. And Olive's got her name back, and all is well in the world. She's quite a bit happier, I think. So there's a few things in this particular controller that I kind of glanced over that I need to mention. Now, when I was talking about the convention over configuration thing, I mentioned that the method that is invoked is derived from the name of the type of HTTP request that comes in. So get to get, put to put, delete to delete. But if you notice here, I have this get by ID. There's no HTTP request type called get by ID that I know of. The reality is that the convention isn't matching the name. The method needs to be prefixed with the name. So from the routing perspective, the get by ID method is really no different than this get method. It sees them as equal. The only thing that delineates the two is basically the existence of a parameter on the route. So this is nice if you don't want to follow this convention. You know, maybe you have a get by ID, get by code, get by social security number. You're not forced into the basic convention-based model. And if you want to ignore that altogether, like I've done down here, you can also use attribution. Now this is something that they took from the WCF Web API. It allows you basically to specify what verb you want mapped to which method. So in this case, I'm saying I want the save method to handle the HTTP put. And the last thing that's interesting about this controller, and those familiar with MVC probably are pretty used to this, is that we're actually getting a Pitbull passed in. If we look at the put that we actually sent to the server, if we look at the raw view, you can actually see we're doing our, oh shoot, that's not right. We're actually doing our HTTP put, but all the data we're sending is just key value pairs, standard HTTP. But in our controller here, we're actually dealing with a fully instantiated Pitbull object. And the way this happens, of course, is through something called model binding. We have this in MVC. And this is one of the nice things that we get with the Web API because it's based on MVC. And there's a few things that we'll see as we move forward to the next example that we can do with this. And one of those things is model validation. All right. So any questions on this particular example of the clients? All right. So we saw two examples of JavaScript clients here, right? We saw how we can get data from our service, how we can send data to it. It kind of gives us that snappy AJAX responsive UI thing that kind of defined the whole Web 2.0 thing, right? But what if we can't rely on JavaScript? Let's go back to our organization, PettyLove.org, and we have a really, really know-it-all intern, right? He knows everything. He comes to your cube, knocks on it, and says, I found a service on Google API that is way more dog information than this. It's cheap, or it's free, it's scalable, it's more accessible, and I think we should use it. You kind of bite your tongue and do everything you can, you turn around and you say, out of my cube, right? Get out. But unfortunately, for us, our boss heard it and heard the word free. So interns getting promoted, and you have to make some changes. So we all get into a room, and we have to make some architectural changes. So what we come up with is we're going to have our website. Same thing. Users can go browse available documents. We need to keep the database for some of our other assets that we maintain in there, so we're going to keep that. But instead of using a web API that we host in-house, we're going to use this thing our intern found. And this presents a particular problem depending on what kind of clients you want to support, because the Google API is outside of our domain, right? And depending on what level browsers you need to support and a whole bunch of other things, you may not be able to rely on JavaScript. The reason for this is the same origin policy. Newer browsers, HTML5, are getting around this issue. But still, we need to support older browsers, so client-side scripts like JavaScript cannot make cross-domain calls without jumping through various hoops. So we decided we need to do something different. And it turns out, with the Web API, we have another option. If JavaScript is not something you can rely on, or if you're not even in a web environment, maybe you're doing WPF or Silverlight, and you need to interact with these services. And that's through a class called the HTTP client. Now the HTTP client is a .NET object that allows you to interact with HTTP services in a very nice asynchronous type-safe and task-based way. It takes care of all the serialization issues for you, and it works pretty nicely. But oddly enough, when the Web API was in beta, I was playing with it a lot back then, actually, at a client. They didn't have this class yet. It wasn't available. So we had to use REST-Sharp. Has anybody here used that? REST-Sharp was actually developed by someone in Minnesota. And it was really one of the only options we have. So this is very similar to REST-Sharp, and I'm still a little bit partial to REST-Sharp because I have used it quite a bit and it's worked well. But the HTTP client takes it all a step further. It uses the new threading task-based model. You can use the wait keyword and all the stuff that came out with .NET 4.5. So the next example, what I'd like to do is show you a way that we can use the HTTP client if you're in a WPF space or in a Silverlight space, or you just can't use JavaScript for whatever reason. And the interaction we're going to look at is going to look a little bit like this. We're going to move to traditional MVC, right, because we're not using JavaScript, so we're going to do the standard postback. Browser is going to do a GET request to our index action. Our index action is going to create a new instance of the HTTP client. That HTTP client is going to proxy our call outside of our domain to the web API that's hosted on Google. And Google is going to do whatever it does to get all our data and return to us an HTTP response, again with the payload being a list of dogs in JSON format. HTTP client is going to serialize that into our list of dogs. We're going to hand that off to the Razor View engine. It's going to do its magic, create the markup, send the markup back to the client, and the browser will then render that markup to the screen. So let's take a look at the HTTP client and how it can help us in strange situations like this. All right. So if we look at our controller here, now you can see it is actually a Google service. So we're actually looking at a service out on google.com, and you can tell because it must be because of the comment, right? So we're going to use our imaginations here. We're all about imaginations. So this is running on my web server, which is Google. And it happens to be the same instance that I'm running the website on, but it's still Google. And it looks a lot like the one we had before, which kind of makes me wonder how they got it. But we have our unit of work coming into our controller, and this is just the very basic one that we saw in the beginning, right? I'm going to get the list of dogs and returning it back to the client. Now, because we're not using JavaScript, our view is going to look a little bit different because we're going to be using more of a traditional Razor approach. You can see this is your standard Razor page. We have the model being bound to a list of pit bulls. And this for each is basically replicating exactly what we had in the jQuery template, right? We have our image URL, our name, and our description. Now, where this all kind of comes together is in the action of our home controller. You go here, this is where we're going to start to interact with the HTTP client. I'm creating basically an empty list of pit bulls for the return type. I'm going to create a new instance of the HTTP client. I'm going to call it proxy. Then I'm going to take the proxy and I'm going to ask it to create for us an asynchronous GET task, which is going to make a GET request to our service out on Google. And when that completes, I'm going to continue by creating a read task. That read task is also going to specify to the HTTP client the type of object I want it to attempt to query the incoming JSON with. If that succeeds, I'll grab that result, put it into our list of pitbulls, and I'll hand that off to the Razor View Engine, which will then essentially build up our view like normal. So let me put a breakpoint here and let's just run through this so we can actually see the interaction with Google. All right. So here we are. Again, I missed it. One more time. All right, so here we're in the index action, and you can see I'm creating the proxy. This is going to make our request outside of our domain. And here we are on Google. They actually put the PDBs out there so we can debug it. And I'm going to get a list of pitbulls and return it back to our prettylove.org domain, which will then, oh, that's not right. Can't debug into that. Which will then ask the Razor View Engine to render the view, and we'll display that to the screen. Any questions on this? It's a pretty new class, and if you're not used to the kind of task-based learning model, it's a little bit difficult. And it's actually why I kind of preferred REST-Sharp. It seemed a little bit more intuitive, but I'm getting more and more comfortable with the HTTP client, and like I said, in a Silverlight environment or WPF environment, really it's probably your only .NET option that's worth even looking at. All right. Let's go back to the PowerPoint here. So we've talked about getting data, sending data, saving data, and all that stuff. So the next logical thing to talk about is validation. Now, I know a lot of people here probably work on a lot different things than I do. You know, I kind of end up doing more of the business apps, kind of data in, data out, grind away. And so for me, in my day-to-day job, one of the most complicated things to do is to make validation useful. And in a distributed environment, the problem's compounded, right? You have rules on the server, rules on the client. You have all this stuff that you need to do in between to try to be able to give the user an experience that is at least decent, right? So they can basically take care of any errors. So validation is difficult, in my opinion. So how does it work in the Web API? Well, we saw in the earlier example that one of the things we get is model binding, right? We saw that that post actually converted the HTTP request into a pitbull. Now, if you're familiar with model binding, you know that one of the steps along the way in model binding is model validation. So what this means for us is that any of the ways that we do validation in traditional MVC are fair game in the Web API. Now, this includes things like data annotations and the iValidatable object interface. So what I'd like to do next is show you a few different approaches that we can handle validation. And in both cases, I'll do two approaches, but in both cases, the sequence of events is exactly the same. We're going to make a put request to our Web API. And that request is going to have invalid, missing, incorrect data, right? Model binding will happen. As part of model binding, model validation will happen. If model validation deems our object to be, our request to be invalid, we're going to return a special type of request back to the client. And I mean special because, well, it's a 400 bad request. Obviously, that's something bad, right?